All right, so continuing on with our local extrema and critical numbers. So if f of c is a local extremum of the function f, then c is going to be a critical number of f. So this is theorem number 2. So it states that a local extremum can occur only at a critical number, but it does not imply that every critical number produces a local extremum. So in the figure below, what we see is we see that our c1 and our c5 are critical numbers, and their slope is 0. We cut across there, that's going to be going through, that's going to be where it changes from concave up to concave down to concave up. But the function doesn't have a local max or a local min at either of those numbers. It's just kind of changing. It's always still going negative in this case, and this one's always still going positive, okay? Now our strategy for finding local extrema is clear. We need to find all critical numbers of f, test each one to see if it produces a local maximum, a local minimum, or neither. So again, some of them are going to produce one or the other or neither. Now, our first derivative test is going to help us do a lot of this. So if f prime of x, or the derivative of f of x, exists on both sides of a critical number c, then the sign of f of x can be used to determine whether the point c of f of c is a local max or a local min or neither. So here is our testing. So first derivative test for local extrema. Let c be a critical number. F of c is defined either as f prime of c equals 0 or f prime of c is not defined. So it's going to be one of those two. And we're going to construct a sign chart for f prime of x close to on either side of c. Okay, so if c is going to be like that point where we have something happening or changing. And so we have one where we have decreasing followed by increasing. So what happens here? Well, if it's decreasing followed by increasing, well, we're decreasing followed by increasing. That gives us a local minimum. Now, if f prime of x changes from negative to positive at c, then it's going to be a local minimum. Okay, so it all depends on how you want to look at the way it works, the f prime of x or f of x. So that's going to be kind of how it works. Now here we're going from f prime of x being increasing down to it's decreasing, or our f of x is increasing to decreasing. So now what happens is, if we're looking at the slopes are positive over here, then over here they're negative. So we're going from a positive to a negative, or we're increasing, then we're going down to decreasing if we're looking at the f of x. In either case, we're going to get a maximum, okay? Now, what happens is if we have going from positive to positive, or it's increasing and increasing, well, then f of c is not a local extremum. Basically, f prime of x does not change signs at c, then f of c is neither a local max or a local min. And same thing happens if it stays negative. F of c is not a local extremum. If it doesn't change sign at c, then f of c is neither a local max or a local min. So basically, it's doing something like this, or maybe we're coming down doing something like that. You got the critical point or inflection point where it's doing that, but we're still staying always positive, or we're staying always negative. Okay. All right, so here we have our horizontal tangent line. F prime of c is equal to 0. So here we see that, 0, 0. This one's going to be 0 here, and this one's going to be 0 here. So what's that say? Well, here we're, you know, going and decreasing, and then we're going up and increasing. So that gives us a local minimum. Here we're increasing, going down to 0, and then going down and becoming negative. And so this one is the maximum because we're going up. Here, we're staying positive going up. We just have a inflection point. We're going from concave down to concave up. And so that one's always increasing no matter what. So it's neither a local max or a local min. And this one's decreasing the whole way. And so again, we have our inflection point going from concave up to concave down. And so it's not going to be changing direction in either direction either way. All right. Now here are points where that are not defined, okay? So not defined at a sharp point. So these are points where they're not defined. Here it's not defined because we have a vertical tangent line. Here we also have a vertical tangent line, so it's not defined. All right, so here f of c is a local min. So we're coming in, it's negative. It's not defined here, and then it comes up and it's positive, okay? So again, with this one, we get a local minimum. So it's coming down and it's going up. Here we're kind of coming up and then we're going down. And so that would be a local max. Here, we're going up, switching from concave up to doing concave down, so it's always positive, and so it's neither a local max or a local minimum. And here we're always decreasing. We're going from concave down to concave up. It doesn't change direction. It's always negative, and so it's neither a local max nor a local min. Okay, so basically on these, the derivative's not defined, but f of c is actually defined. Okay, so let's stop there and we'll come back for some more.